When considering the place of origin of the universe prior to the Big Bang and what the prior state was, if any, the initial cause of the Big Bang becomes a crucial question. Prior to a few centuries ago, the response was easy. Everything was set by an eternal God. Even Isaac Newton believed that the universe was created by God, some 6,000 years ago. Later, many scientists, including the young Albert Einstein, assumed the universe as a whole to be infinite and unchanging. Of course, stars could die, planets could collide, killing those who live therein. Civilizations could arise and fall. But over long periods of time and on large scales, the universe always looked roughly the same as it does now. During the 1930s, convincing evidence of the expansion of the universe appeared. And in the 1960s, evidence of its beginnings. The Big Bang was such a radical shift in the worldview of science that nothing comparable had occurred, possibly not even the recognition of the heliocentric system. But then two equally difficult questions arose to one. What actually was before the Big Bang? What was space like before it began to grow, and how long did it remain there, this primordial state? 2. Everything that has a beginning has an end. Therefore, at what point will our universe end? Brian Cox, an English physicist, set out to find an answer to this question. Now, in an unprecedented revelation, physicist and professor of particle physics Brian Cox has declared that he strongly suspects the universe existed before the Big Bang, putting the theory of our origins on its head. We used to think the universe emerged in an extremely hot and dense state at the beginning, that used to be known as the Big Bang. However, we now have strong suspicions that the universe existed before that. In that sense, time can be talked about before the Big Bang. Come dig with us deep into how Brian Cox just debunked the idea of the Big Bang as the absolute beginning. Professor Brian Cox transformed his field of science in the 21st century into something accessible to everyone. Regularly contributing to public debate and discussion, never one to shy away from big questions. He previously took up the narrative of the Big Bang. The Big Bang concept first appeared in the 1920s and 1930s. When we looked out at distant galaxies, we discovered something strange. The farther they were from us, the faster they appeared to be receding, according to predictions based on Einstein's relativity. A static universe would be gravitationally unstable. Everything had to move either apart from one another or collapsing inward. The fabric of space obeyed his laws. From this apparent recession, we learned the universe was expanding. Today, if things are getting farther apart over time, it means they were closer together in the distant past. An expanding universe doesn't just mean distance increases over time, it also indicates that light existing in the universe stretches. In wavelength, as we move forward in time, since wavelength determines energy, this indicates that the universe shrinks with age. As a result, things were more heated in the past. If you extrapolate this far enough back, there comes a time when everything was so hot that not even neutral atoms could form. If this image were accurate, there ought to be a lingering glow of radiation today in all directions, cooled to just a few degrees above absolute zero. The discovery of this cosmic microwave background radiation in 1964 by Arno Penzias and Bob Wilson was a breakthrough, recognizing direct evidence for the Big Bang. It's tempting, as a result, to continue extrapolating to the very beginning of the universe, when it was even hotter, denser, and smaller. If you keep going back, you find a point in time when it was too hot to form atoms, where radiation was so intense that any bound protons and neutrons would be blown apart. During that time, pairs of matter and antimatter could spontaneously form, just like in today's universe where it's energetic enough. Pairs of particles and antiparticles can be spontaneously created. There was a time when individual protons and neutrons disintegrated into a quark-gluon plasma. This creates an extremely different picture of the beginning, not the sudden emergence of time and space from a singular state, but something else. Entirely. Now, we get to address the really big questions. What does all of this indicate about the actual beginning of the universe, if such a thing even existed? The bottom line may be the most important. The Big Bang did, in fact, occur, but It does not trace all the way back to an arbitrarily hot and dense state. Instead, the very early universe underwent a time period called cosmic inflation, during which all the effort required to tackle the problem and radiation present today was instead entwined with the structure of space itself. That time period came to an end and gave rise to the hot Big Bang, but never created an arbitrarily hot, dense state, nor a singularity. Whether or not inflation was eternal into the past is still an open question, but there is one certainty. The universe did not begin with the Big Bang. So if the Big Bang wasn't the beginning, what was? What happened before it? Short answer, we don't know. Long answer, it could have been a lot of mind-boggling things each. In its own way, it's possible that before the Big Bang, the universe was an endless length of extremely hot, dense material that maintained a constant state until the Big Bang for some reason occurred. This extra-dense universe may have been ruled by quantum mechanics, the physics of the extremely small. The Big Bang, then, would have represented the moment that classical physics took over as the primary force behind the universe's evolution. 4. Stephen Hawking, prior to this, nothing else mattered. The events he described as the Big Bang were unmeasurable and thus undefined. Hawking called this proposal the no-boundary model, in which space and time are finite, but without boundaries or a starting point, just as Earth is finite, but has no edge. Or there might have been something else prior to the Big Bang. Pondering. Professor Brian Cox's bold idea. He asserted that there was a time before the Big Bang when the universe did not exist at all. He stated this in his documentary series Universe, claiming that before the launch point of the Big Bang there was no matter at all. All that existed was space-time and an ocean of energy, almost still but gently rippling. This place, as he said, should be imagined as a near-infinite ocean of energy filling the void. It would have been devoid of structures. It would have been brought to expansion by space energy stretching violently, something known as inflation. Brian Cox turns the creation story on its head. He continued to describe the scientific creation story. The area known as inflation had an impact on the ocean when inflation brought an end to the ocean. The transformed energy turned into matter. The ripples pattern and the Big Bang etched their mark on the universe as areas in which the density was slightly different and the gas made of hydrogen and helium immediately followed the Big Bang. The denser regions collapsed. The result was the formation of gaseous regions, the first galaxies and stars. And 9 billion years later, a new star was born. The Sun, our star in the Milky Way. 8 planets, including Earth, joined in, at close to 13.8 billion years. Later, we emerged, blinked into being at the beginning. Especially Brian Cox isn't the only one to engage in such a debate regarding the remarkable beginning of the universe. The study of theoretical physics has revealed a potential entry point into the early universe that suggests it might be just the latest iteration of a bang-bound cycle that has occurred at least once, possibly always. According to the study, we've learned a lot about the early universe, an incredibly complicated mix of high-energy physics and general relativity. We can only go so far with particle physics before giving up and attempting to push deeper into the beginning of our cosmos. The math gets more difficult to solve, all the way to the point where it simply ends. The primary indication we have of unexplored terrain is the presence of a pointor singularity at the beginning, a point of infinite density. If we take the Big Bang as a whole, this tells us the universe once existed squeezed into an infinitely small, infinitely dense point. This is obviously absurd, and the truth it reveals is that new physics is required to resolve this problem. Our current toolkit simply isn't good enough to save the day. We need something new. Physics is something that can manage the other forces in gravity, merged at extremely high energies, exactly as stated by string theory. If a physics model is capable of dealing with gravity and other forces working extremely well together at such energies, string theory claims to be able to explain it. One of the earliest ideas in string theory is the eerie universe that originates from the Greek word for fire or conflagration in this situation, which we call the Big Bang. But something else sparked the bang. prior to the Big Bang. It was not the beginning, but one part of a larger process of expansion. The idea has resulted in a new theory, fueled once more by cyclic cosmology, also known as string theory. Technically, the idea of the universe repeating itself repeatedly predates thousands of years of physics. But string theory provides solid mathematical support for it. The universe operates exactly as you would expect if you imagine moving back and forth between large bangs and significant crunches, maybe forever, backward and forward in time. Despite how cool this may sound, the cyclic model in its earliest stages had difficulty aligning with observations. That is a significant issue when attempting to do science, not just tell stories around the campfire. The main hurdle was confirming our observations regarding the cosmic microwave background, the fossil light from before the universe existed, dated back only 380,000 years. Despite our inability to see directly beyond that wall of light, theoretically speaking, tinkering with the infant cosmos, physics has an impact on that afterglow light. The pattern gave the impression of a cyclical universe, neat, but flawed. However, the eerie torch has been kept burning. In the past, and in recent years, physicists have studied numerous wrinkles in the math and discovered a few missed opportunities. Researchers investigate the big theory, the bounce implying that the universe is expanding, standing and bending over backward and forward in a massive big picture timeline. Some bouncers believe this happens only once, whereas others believe ours is a universe created by cyclical bouncing. Despite the ongoing debate, the big bounce requires significant leaps that must be explained with an understanding of science. Waving proponents say, it's a lot less flawed than using a Big Bang model. The Big Bang, as told, has fatal flaws. It is based on the concept of inflation, particularly the field of cosmology. Regarding the rapid expansion that followed the Big Bang, it has some grand and creative ideas. But critics of inflation theory argue that it is too neat possibly. Contrived, however, inflation suggests an infinite number of universes, the one we can observe being only a single, isolated bubble among many. This challenges the idea that there is only one beginning and prompts questions about what might be out there beyond our own bubble. Alternatively, those in favor of the large bounce theory suggest that the universe may provide a more comprehensive explanation. This theory calls for a multiverse and proposes that prior to the Big Bang, there existed a separate universe with entropy advancing toward the past, indicating it's possible that time moves in the opposite direction in that universe. This anti-universe idea might explain dark matter as a type of particle called a neutrino unique to its own universe. In addition to expanding the CPT symmetry throughout the universe, it entails the existence of a cosmic mirror image, a universe that entirely reverses parity and time. An identical universe operating under the same fundamental symmetries may be responsible for phenomena like dark matter and the universe's expansion without needing periods of inflation. Ideas like these challenge traditional views of cosmology and suggest there is still a lot to learn and investigate about the nature of the universe. The CPT mirror universe hints at an existence beyond our Big Bang and, possibly before the beginning of the cosmos we can observe. Researchers suggest a few observable consequences. Neutrinos ought to have Majorana behavior, meaning one neutrino species should be its own antiparticle. This ought to result in a significant, massless, testable prediction in this model. In it, the universe never experienced inflation. It was naturally stuffed with dust. The absence of primordial gravitational waves, if experiments prove them, could support this model. Comprehending the universe's beginning pushes the boundaries. We are unable to understand the origin of the universe with certainty, which hinders our achievement of a complete theory of everything. Scientific progress has revealed a comprehensive history of the cosmos, but there are still gaps like the nature of dark energy and dark matter. The initial cause remains a mystery. Humility in the face of the unknown and like supernatural justifications relies on evidence and data rather than faith.